Hello, welcome to Evangelistic Apologetics. This is a systematic introduction to Christian worldview. We are in the overall part 3, the science of science, or the study of what is science. And this is part 3 of that. We are talking about the practice of science. And I have been a practicing scientist for years, and I kind of know how it does, how it lives. And I think every practicing scientist know it. And it's just not necessarily systemized. And right now we're trying to present, this is how scientists live. This is how science works. Okay, so what is science? Well, science is, at the end of our last session, we concluded science is a theory that studies nature in general. Okay, the object of study is nature, but it can be extended to everything else if you use a scientific method. Okay, it's the science of something, but generally it's nature. And science, a theory can be claimed to be scientific not only for its object of study, but also for it is a collective opinion of the most professional scientists, and that can say this is scientific. But we need to be aware not to develop science into an ideology of scientism. Okay, once you go to ism, and it becomes an ideology, a philosophy, and it can become another Catholic religion, the universal religion. So today people are saying, oh, this is not scientific. That means, okay, this is not orthodox in our universal faith, which is Catholic religion. But now we ought to make science what it actually is. It's a study of nature. Okay? It's the collective opinion of the scientists on what nature is. That generally is what science is. And a theory is scientific if it follows the logical procedure and it uses the full scientific method and it satisfies the standard of truth. Okay, so let's go into detail. What does science do? Well, science uses the logical procedure to study nature. Okay, so what is logical procedure? Well, it is called induction and deduction. Okay, and induction is a summary from the specifics into a general claim. Okay, for example, okay, I see one chair there is gray colored, the other is gray colored, and another is gray colored. So these are specifics I see. Okay, I say chair 1 is gray, chair 2 is gray, chair 3 is gray. Then I can make a general claim. I say all the chairs in this room is gray colored. See, that's from specific to general. And then is that true? Well, it is true if I can test every chair. If I can see every chair in the room and find out they are actually gray colored, then it is true. But what if I find something, oh, that one is brown? Well, then this theory has some errors, and it needs to be modified. So we can say, well, through the deduction to say that chair should be gray. But I checked it, I experimented, and I found out that it is brown. So what we do is we limit the range of the theory, and we say within this range, on this side of the building, all chairs are brown. Then you make another deduction, and then you check. So if this case it was falsified, in the other case it is verified, then you know the theory can be modified to stand within that range. You see, that's a logical procedure. So you use the induction. It's experimental based. It gives a scientific proof, and then you use deduction. It's a theoretical based. It's a logical proof, and you use this repeatedly. And science goes forward or progresses when you use the logical procedure repeatedly to study nature. Okay? That is what science does. Okay? But of course, we know that nature is nothing but a part of the objective world. So if we look at this basic epistemology we've given you in our part 1 of our series, that there is an objective world and there is a subjective world. The objective world exists with or without us thinking about it. The sun is there, the moon is there, we see it or not, it's there. Okay? And that's part of nature. How about when you go to man? Man has thoughts, and that's not visible. And then when you go to the supernatural, they are not even governed by natural law. And so the objective world can be divided into 3 levels, and the way to know them is what I call a midjective world. It's a mixture of both objective and subjective world. It's part of our mind, but it exists in our mind even before we use it to think. So it's both objective and subjective. So the 3 ways of knowledge: experience, the basic one; reason, the middle one; and the faith, the highest one. So these 3 are the ways to know nature, man, and the supernatural world. And the result of that is science, philosophy, and theology. Okay? So what is truth? Truth actually is all of the accurate reflection from the objective world to the subjective world. Okay? That includes science in there. Science is part of truth, but not all the truth. But the scientific method can be used in study everything. Okay? So that is going from special to general, the induction; from general to special, the deduction; and the experimentation, either for validation or falsification. Okay? If a theory can be experimented, may be falsified, then the theory is generally considered potentially scientific. Okay? If it cannot be falsified, then there's no way of experimenting it. It's just something of faith. Okay? And that will make the theory not scientific, but simply philosophical, okay, or religious. So what? Since science uses the logical procedure, but are all objects of study possible for using all of the scientific method? I'm talking about there are 2 parts. Remember, there's an inductive part, there's a deductive part of the logic procedure. Okay? So when you go from special, which is generally you get by observation, and to the general claims, which you get it usually by abstracting and by giving a theories. So from the special to the general, this part is part 1 of the scientific method. Okay? The part 1 can be used in study everything. Okay? Part 1 is to observe your objects. Okay? Observe your objects, and once you observe it, you can collect evidence. You try to collect everything that is related with it, and then you can hypothesize, and you say, well, something that's not obvious, but I think there's something behind it. Okay? And such as, let's see, you can never see an electron, but you see the effect when you put an electric field onto 2 diodes and on 2 plates, and then you see that something flies from the other side, and you put a screen there, and it has light coming out. So you see the surface, you see the phenomena of the light coming onto the, let's say, TV screen, okay, or monitor screen. And you can control it by changing the electric field. And then you know, okay, there's something flying from one side to the other. Even though you can't see it, you call that is an electron. That's an hypothesization of there's something existent. Even though you don't see it, you hypothesize there's an electron. And then you form a theory, okay, that atoms are composed of a nucleus and electrons. And so that's forming a theory. Okay. In this is simply observation and the abstraction and the forming a theory. And there is no definitive answer on whether or not the theory is true. it's something that you summarize. It's potentially true. It may be partially true, or it may be totally false. Okay, you see something happen in chronological order does not necessarily mean that they are cause and effect. They are related. It could be a coincidence. So how do you make sure that this is definitely true? Well, you have to use the part 2 of scientific method, and this only applies to part of your object of study. Okay. For example, science studies nature, right? In part of nature, you can do controlled experiments. You can have experiment, a lab, put things in there, put it under controlled conditions, then you can test or experiment on it. And once you test it, then you can know, if it fits, it's validated, or if it doesn't fit, it's falsified, right? And then you can improve your theory. You can say, okay, I limit it to a certain range. Then I make another deduction and see if it fits. And then now from falsification, now it's validation. Okay? For example, Newtonian physics. Okay? Isaac Newton, he observed, let's assume it's true, the fall of the apple from the tree. So he hypothesized the theory of gravity. He believes that every two objects that have mass, they will attract. This is called gravitation. And he found out by observation and the law of gravitation. So that's the theory. And whether or not that applies to everything was ways to be tested. For about 400 years, it was tested to be true almost in everything. Okay, the Newtonian laws of mechanics. There are 3 laws. Okay, and the laws of inertia. The F equals ma, force equals mass times acceleration, and then the action and reaction are equal. So these Newtonian laws and the gravitational law, they are all affirmed until modern times, when we find out that it does not work for high speed situation. When things move as fast as the speed of light, close to it, then the Newtonian physics does not work. It fails. Okay? But Albert Einstein invented the theory of relativity, special relativity and general relativity. Well, does it work? Well, I found it works. Until now, it works in every situation. Okay? Until recently, there was a improvement, expansion, not refutation, but an expansion of relativity into the cosmological relativity by Moshe Carmeli, another Israeli scientist. And until then, Einstein theory had been all working. Okay? So the theory had been improved. Did relativity refute Newtonian physics? No, it didn't refute it. It just set its limit. You see, the limit is low speed, macroscopic. Okay, when it's too fast, you go to relativity. When it's too small, you go to quantum mechanics. Okay, but when it's normal size and it's a normal speed, then it still works. So it simply set its limit. This theory was improved now with relativity. Then you can decide your opinion. You believe it or not believing it. And now people still are deciding whether they believe relativity. Because if you believe in relativity, then you believe in expanding universe. While for an expanding universe, you go back, you contract it, you have a beginning of the universe. Well, that lets you think about the creation. See, a lot of people still don't like that. They still want to have a steady state universe. Until now, there are still legit scientists who are giving theories to trying to refute the theory of relativity, and in order for their theology actually to stand. Now, if the universe is eternal and steady, it itself is the eternal being. It does not need an eternal being to create the universe as a contingent being. You see, so you decide your opinion, based on your evidence. If you're truly scientific, you should let your evidence decide your opinion, not let your opinion to decide what evidence to look at. Okay, and that's a scientific attitude. That's where we're going later. And finally, you will apply the theory to life, such as technology today is the application of science, mostly, blessing people's life. Okay, and once you do application, then people usually don't have any argument anymore. Okay, the problem is the scientific method only applies to limited amount of objects of study. Okay, for nature, there are certain things you cannot control. Okay, there are certain things that are too great for you to be able to observe. The universe is so great, you can only see the lights and the electronic waves that comes here, but you cannot be there. And so in a sense you're limited. And for the microscopic particles, for quantum mechanics, if you want to see a particle, you must send a light particle, a photon, to hit it, and then the photon reflects back, and then you see how it has changed to know what it is. But if that thing is small enough, when you hit it, it changed. It's not what it was. Okay, think about it. If you want to know the heart of a live animal, you have to send something in there to see it, a scope to see it. But if it's so small, the scope could kill it. Then you don't know what it is. So that's what's happened with quantum mechanics. If it's too small, when you want to know it, then it's not what it was. So that's why we're saying there are certain things that are limited beyond our ability to observation. There are certain things in society that it is simply unethical to do experiments on. We know that the Nazis and the Japanese, they did experiments on humans. And they put in medicines, drugs, and test how will they die, and then in something. And it was just simply unethical. And you cannot do that kind of experimentation. For society, we know the modern time there has many experimentations on society, on whether or not it is an ideology would work. Science, socialism, communism, and all kinds of models, and Keynesian economics, all of them have been experimented. None of them worked perfectly. They all have flaws. And is it ethical to experiment on the whole group of people without everybody's agreement? That's a question. The social experimentation has ethical problems. So anyway, we're saying that the scientific method is limited to only certain objects of study. Okay, for nature, mostly you can do it. For mankind, there's already a problem. So certain societies shouldn't do it. How about for the supernatural? You can't do it. You can never say, God, come down, let me put you in a pen and let me subject you to experimentation, and probe you with something. It never works, right? Because he's too great, and he's not going to be subject to your command. So that's why we know that scientific method, we should stick to it, but we must know its limitation. Okay, and then when you cannot use all of it, in general, the part one can be used by everything. So if people stick to part one, then the theory is half scientific. Okay, it's objective. We say this is a good observation of society, like a historical analysis. It's, if it collects all the evidence and try to be impartial, and it forms a theory, and that seems to make sense, and that is half scientific. A good history writing is half scientific. But on the other hand, is there any history writing without bias? Hard to find, right? So its limits. Now the second part, if you have it, then the theory is fully scientific. If you don't, then it's partial. Okay. Now, with these limitations, how do scientists live and do things, knowing that they are limited too? Okay. And the scientists have schools, and they have a teacher student, some kind of in a sense, it's against and against tribes. There's a certain tribalism, and even in the scientific community. And even though we're not supposed to have it, but as humans, we have it. Okay, so how can we do our best trying to be scientific and objective and true? Well, we need to have the scientific attitude. Okay, the scientific attitude is to be an open-minded doubter and an open-minded believer. Okay, when you have a new theory, you don't immediately say, "Oh, I believe it. This must be true because it agrees with my heart feeling at heart." Well, you may have that sense, you may have that feeling, but you cannot decide your opinion. For a true scientist, he must be a doubter first, a believer later. For all theories, he must doubt first. Okay? And then only through experimentation and the validation, then he increased his faith on the theory. Then he became a open-minded believer. Okay? You want to be a skeptic, okay, first. And then you want to be a believer later. This is the difference between a scientist and a believer of a religion, okay, a Christian or not, okay, because a believer starts from trusting, and a scientist starts from doubting. Okay, so if people are very quickly jumping on, say, "I like this theory, so I believe it," well, that's not scientific. Okay, and that's not a scientific attitude. You must be a skeptic first. Wait until you know how it's proven or how the evidence has been presented, collected, and are there doubters in the community of professional scientists? If they are, then you probably should stay away and say, "It's not sure," So don't make yourself a fool. By jumping into something. For example, the so-called climate change has recently been put into doubt because some people jumped the gun. They thought that the evidence proves that ever since the Industrial Revolution, the temperature of the Earth is increasing steadily, like a golf club, shape. But the fact is, after the time he wrote that paper, right now, the later decades, temperature actually start to drop. So the person made himself into a fool by jumping into a belief too quickly. So we need to have scientific attitude, okay? Be a doubter first and believer later. And we need to hold scientific character, okay? That means we need to be honest, okay? And make sure that I don't know everything, but I try to know. And be honest, be truthful, knowing that I have bias. Everybody has bias, but we try to minimize the bias. We must be humble. You don't reject a theory. "Oh, this is a young little guy's opinion," then it will never be considered. Well, when Einstein wrote his paper, he was just a patent agent. He was a nobody. Okay, be open. And anytime an existing theory could be proven false or improved, that means partially false. And need to be fair. Don't just worship the great guys, And great guys need respect, but you need to be fair to the little guys, and they might have the right ideas. And be truthful and truth-seeking. Okay, you seek for truth, and you fill yourself with truth. That is what scientists should have as a character. And finally, we'll go to scientific standard. When you have theories that compete for the position of truth, okay, then how do you decide which is more likely the truth? Okay, so we start from what's the standard of truth? That goes back to our basic epistemology. You have three ways of knowledge: experience, reason, and faith. And in these three ways, you're supposed to fit three standards. Experience or experimental level, you must fit the facts. Whatever can be verified, the facts. And on the reason level, you must fit logic. Okay? Logically, it has to be self-consistent. It cannot be contradictory. If it is, then the theory is not true. Okay? And in terms of faith, well, since faith is trusting in the revelation from the supernatural, it must fit the scripture. Different people have different scriptures. They have different faith. And that's why for scientific discussion, rational discussion, we only use the bottom two. Okay? That's what the scientific method, a standard, that's where it comes from. Okay? So, at the bottom, science is primarily an empiricism. Okay? Experiments is the king in science. If the experiment says this is true or this is false, and then you accept it, and you cannot argue with facts in science. Okay? So, however, we know that our experience is limited. So that's why we say it's a realist empiricist. We know there are real things beyond our experience. Okay? So when you use scientific standard, first of all, you're trying to find if you can have proof. The proof is can only exist for limited situations. If you want to have a proof, you must experimentally check all possibilities. What if it's too big? You can't check everything. Then proof is not there. You can only have evidence. Okay. Now, evidence will you know that you don't have everything. You can have a few evidences. Then you need to examine each result, the probabilities of each result. Okay, and you kind of know that each evidence is not strong at the same level. Some are stronger, some are weaker. So you have to find out the stronger evidence, go with them, and the weaker one explain them. Okay, and that's the evidence. After this, you must find the compatibility, because it will fit logic, right? So it has to be compatible. All truths must be agreeing with one another. So all the accepted established theories are your standard to judge the new theory. Okay? And finally, you have a standard of beauty. Now, scientists also believe in beauty? Yes. In science, a theory that has the fewest assumption that needs faith. It has the widest experimentation evidence. Okay? And it's the simplest in structure. In other words, it is a pyramid with a small head on top. Okay? That kind of theories is more likely true. But it's an inversed pyramid with very few experimentation and proof and a lot of assumptions. That's not likely to be the truth. Okay? Then because it's not so beautiful. So overall, it is a rationalism. You believe reason should be able to explain things, but it's reductionist in the sense that you want to reduce the number of faith, number of assumptions. Okay? So in this way, you will distinguish, separate scientific theories to find out which one is more likely to be true, which one is less likely. Okay? So that is the scientific standard. And the top here is, we find out it's science, and basically it's experimental. The top, we find the science basically is looking for truth, and truth is what makes us free. Amen.